Hello, everybody. Today we are going to learn about Colorsys Python module. Conversions between color systems. It is useful for web development or GUI applications. Before we start, please, give a like to this episode so more people can see it. Subscribe and turn on notifications so you don't miss the next episodes. Let's go. The Colorsys module works with four most popular color spaces, RGB, HSL or HLS, YIQ, and HSV. Let's see what these spaces are. The RGB color model is an additive color model in which the red, green and blue primary colors of light are added together in various ways to reproduce a broad array of colors. The name of the model comes from the initials of the three additive primary colors, red, green, and blue. RGB color spaces are commonly found describing the input signal to display devices such as television screens and computer monitors. HSL, for hue, saturation, lightness, are alternative representations of the RGB color model, designed in the 1970s by computer graphics researchers. In these models, colors of each hue are arranged in a radial slice, around a central axis of neutral colors which ranges from black at the bottom to white at the top. The HSL representation models the way different paints mix together to create color in the real world, with the lightness dimension resembling the varying amounts of black or white paint in the mixture. YIQ is the color space used by the analog NTSC color TV system. I stands for in phase, while Q stands for quadrature, referring to the components used in quadrature amplitude modulation. In YIQ the Y component represents the lumen information, and is the only component used by black and white television receivers. I and Q represent the chrominance information. HSV, for hue, saturation, value, also known as HSB, for hue, saturation, brightness. The HSV representation models how colors appear under light. The difference between HSL and HSV is that a color with maximum lightness in HSL is pure white, but a color with maximum value/brightness in HSV is analogous to shining a white light on a colored object. For example, shining a bright white light on a red object causes the object to still appear red, just brighter and more intense, while shining a dim light on a red object causes the object to appear darker and less bright. And once again, the Colorsys module defines bidirectional conversions of color values between colors expressed in the RGB, red, green, blue, color space used in computer monitors and three other coordinate systems. Coordinates in all of these color spaces are floating point values. In the YIQ space, the Y coordinate is between 0 and 1, but the I and Q coordinates can be positive or negative. In all other spaces, the coordinates are all between 0 and 1. The module has three constants, 1/6, 1/3, and 2/3, and also has 6 conversional methods that we will see in examples. Import module Colorsys, and look at all attributes and methods it has, using dir function, and magic method named all. Next, let's look at constants in library. We will test module methods on hexadecimal color code number 366, that is called a medium dark shade of cyan. RGB2 methods. Color spaces conversions here. And let's try to get RGB color from others, but it's hard to be accurate. Thank you for watching. Please, give a like for support this channel. Write comments, share with friends, and subscribe to see new series. Be safe.